Hi, this is Chris, and welcome back to Chapter 11. We are going to talk about cardiac axis and axis deviation in this video. Okay, so you have the horizontal plane is what we're talking about here, and there's the degrees that are associated with direction. And remember, we are only using 6 leads to determine axis. So the 6 leads are the ones identified around that circle. And if you, with the conduction system in there, just kind of understand that normally the sinus node is where an action potential starts, and then the flow of electrical activity goes down through the AV node into the bundle of His, and then the bundle branches in Purkinje fibers in a direction that heads towards lead 2. So we understand that in a typical patient or in a patient with a normally working conduction system, you're going to have some variation. All right, so a normal axis is anywhere from -30 to 90 degrees. So a trick that I'm going to teach you to do is to put your thumbs up. All right, so you have your thumbs up, you have lead 1, which is associated with this left thumb, and you have lead AVF, which is associated with the right thumb. So when both of those leads are upright, as they are in this 12 lead that you're seeing here, remember, we're only talking about the horizontal leads, so leads 1, 2, and 3, and then AVR, AVL, and AVF. If we have 2 thumbs up, it indicates that leads 1 and lead AVF are upright, indicating that our axis is heading into that quarter region. But remember, we are also talking about this area, this from 0 degrees to -30 as well. That would be a normal variation if the axis is headed in that area. And you can see, depending on what type of 12 lead that you're using, the QRS axis will typically be identified on that 12 lead printout. So let's take a look at what happens when a person has left axis deviation. All right, in this case, we have lead 1 and AVF identified by our thumbs, right? But lead 1 in this case is upright and lead AVF is down. Therefore, we have left axis deviation. Okay, my left thumb is the one that's up, so we have left axis deviation. Again, just a little trick to help you remember this stuff. So what is happening here is we have a direction that is heading over to the left side of the heart and kind of deviating away from the right side in a somewhat pathological way. All right, remember, we don't want to include that -30 degrees area. And what you can do, a little tip, is to confirm it with lead 2. Lead 2 should also be down to determine left axis deviation. Even if it's pretty flat, but just slightly down, that would be an indication that you have left axis deviation, provided that you have AVF and lead 3 are downward as well. All right, so why does someone have left axis deviation? You can pause the video and take a look at those different reasons. Okay, another example of left axis deviation with ventricular tachycardia. So this is a VTach example. So you can see we look at leads 1 and AVF. In this case, lead 1, it's hard to tell, but it is slightly upright. So lead AVF is down, indicating that we have left axis deviation. And you can see that it's identified as -53 degrees. And another tool that you can use, you can see how AVL and AVR are upright. That gives you an idea of how you can use the 12 lead to identify the axis and get an idea of what's going on with your patient. All right, moving on to an example of right axis deviation. So now we have our thumbs technique, okay, and in this case, lead 1 is down. So my left thumb is down, therefore we have right axis deviation. So the right thumb is up, kind of pointing over to the right, and that indicates that we have a direction of our summation of electrical energy. The vector is heading towards that right side of the heart. So look at leads 1 and AVF. In the picture there, you can see lead 1 is a little bit upright, but it's mostly down. So we would consider that to be down as a total. And the reasons that you might have right axis deviation are shown there. So again, you can pause the video to see some of the different reasons that you might have right axis deviation. And then an extreme axis, sometimes referred to as no man's land, that would be identified by the area shaded in the upper left corner. Any of the potential causes for LAD or RAD can be associated with an extreme axis. So you can see with the image over there on the right, again, we are looking at leads 1 and AVF, and in this case, we have both thumbs are down, indicating that we have extreme axis deviation. You see this sometimes with ventricular tachycardia, and you can see if you look at AVR in this one, you can see how AVR is upright. So AVR being up here, it's a way that you can confirm that the person has extreme axis deviation. And you see this often with ventricular tachycardia because the rhythm is originating in the ventricles and going up towards that right shoulder in the opposite direction that we would expect. All right, I hope that's helpful. I will see you in the next video. Thank you.